Good afternoon, everyone. Thanks for coming to this session. It's the last session in the OMP Summit, and I really appreciate that you stayed with us, at least until the real end. The topic of today is the lockdown, Zero Trust Architecture with Zowe. Disclaimer, Zowe is not giving you Zero Trust Architecture. Zowe can play a role within it, but it's not Zowe, Zero Trust Architecture. So let's talk a bit about what the Zero Trust Architecture is. If you are bored, all of you, just raise your hands, and at some point I will just speed up the Zero Trust Architecture introduction. So first, there are some claims that the Zero Trust Architecture says. First is, there is no perimeter. It's not like you can create a boundary around your city and nobody will pass through. That's not true anymore. Bring your own devices, IoT, and other trends. Just say, this is not gonna be the case. Hybrid cloud is the same problem. So when you don't have the perimeter, how do you defend yourself? And this is one of the answers that we will hopefully see, at least partially. Another problem, or like claims that are linked to the Zero Trust Architecture, is never trust, always verify. Because one of the problems that we are seeing with the security breaches in the recent time is that there was some trust that shouldn't have been there. Like, for example, somebody got credentials of someone, but just some of them, so there was no MFA, but it turned out that for some of the privileges, it was enough just to have the credentials. If they were verifying more, they would get rid out of it. And as add to it, if any of us believe we are not breached, we are wrong. Most probably we are, we just don't know about it yet. The mutual authentication, so not just that if you are reaching something, the service verifies that you are you, but you also need to verify that the service is the service, because that doesn't have to be true. It's very much visible when you are building solutions. So, for example, when you are building your service, it's possible that there are some problems that are happening with your built environments that mean that the final delivery, the final buildable things, is not what you think it is. It's actually pretty dangerous. Then you need to figure out how do you have a confidence in the identity of the user. Because traditionally, and even more so traditionally in the mainframe, it was quite enough to just have either the credentials, so username and the password or passphrase. It's changed over the time with the multi-factor authentication, but even the multi-factor authentication as it is done today with the solutions is still quite limited. It's like out of band or something, you just provide second factor. But there are other things that are playing a role in whether you should really have access to the resources. And is this person who the person claims it is? Is he in the right location? Well, it's my employee. He should be in Germany. But why is he trying to log in from Nigeria? There is no good reason for that. And as we see, the MFA and the user authentication is part of it. And there are actually vast other sources of the data, and we will come to it, that you should also use when you are trying to figure out whether the person should have the access in order to limit the risks. But of course, limiting the risk has price. Continuous authorizations is linked to the fact that you shouldn't give the rights for too long, because if somebody steals the credentials, tokens, certificates, then as long as it's valid, it's just there, they can do whatever they want and they can hurt you. So the shorter, the better for you. And an important topic for the Zero Trust is actual visibility, transparency, and analysis of the data, of the patterns, of the access information that are there. So there are some beliefs that the ZTA, if you are looking into the different white papers and everything, more or less believe. Network is hostile. It's like if you are going to sewers. Let's go to the sewers. It's actually a pretty interesting experience in many cities, but be careful about the hygiene. Otherwise, you might get some interesting sicknesses. And that's the same with network, actually. There are threats out there all the time. There are always someone who would like to get the data, to get the money that you have, or maybe just the information about your employees, about their health state. Maybe there is an ex-husband or still husband that just wants to get more money out of the divorce. It could be an attacker. And if it's a hacker, it could be dangerous attacker, actually. because someone claims to be someone doesn't mean that they are. And more with the breaches and the fact that most of the people are having pretty terrible passwords. Like last year, it still was like 40% of people were having easily breachable passwords, like password 123456778 and stuff like this. So like the probability that someone just randomly gets to your system is far higher than you would believe. Actually, I hope you would believe, but quite high. And one of the problems is that the risk is changing over time. So if at some point in time you say, this is the right approach, then 6 months later, it's already useless. So what needs to be done is that it needs to change as the threat actors are changing, as the whole landscape is changing. The whole policy that's behind it must change as well. So what are some of the components? We will see in an image just on the next slide a bit more on the architecture and how it looks like. But there are some key parts in the data plane and the control plane. In the data plane, it's the point which decides whether somebody has access. It's the policy enforcement point, which is basically where the Zowe could play a role, but we will get to it. And then the control plane that controls how the policy looks like, what's relevant in the policy at the moment, and only the policy enforcement point communicates with these. Like the other services shouldn't be able to directly access them because this otherwise brings lots of potential risks to the whole infrastructure and architecture. So the next important topic for the ZTA is data sources. If you don't have good enough data, then you can do whatever you want, but it's not going to be secure ultimately. These are like the most common pieces of the infrastructure and data sources that are being used at the moment. It's going to change. Like it's valid for the next months. In 3 months, it will have literally zero validity and it will be different. But right now, it more or less is. So threat intelligence, activity logs, data access policy. So basically, anything that tells you what the people are doing, where they are, how they are behaving, what they did before, the historical data around them, what the other services are they were accessing, why they were accessing these services. All these informations are sources to let you decide, is this still the person that they claims it is? For example, the way you move with your mouse is unique enough that if you actually have the data, you can distinguish the people. So if at some point the movement of the mouse changes, it's highly probable that it's a different person doing the things. So with the right data, you can directly distinguish this on the policy enforcement point and remove the access for the person at that time. So this is how it more or less looks like if you are looking at the Zero Trust architecture overall. So you have the data sources that we were shown on the previous slide coming in. So CDM, industry, threat intelligence, activity logs. Then there is the subject that asks for something as an untrusted person towards the policy enforcement points. The policy enforcement point consults with the policy engine and policy administrator in the data plane or in the control plane whether the user is who it is and whether the user should have the access. And then based on this, either reject it or support it. So this is just a nice image that's showing the same I showed in the previous slide. So some things that you need to do if you want to actually support the ZTA. So anything that wants to be part of the Zero Trust must be connected to the internet or at least to the network. It doesn't have to be internet. It has to be network that has access to the policy enforcement point. Everything has to have this access. You need to have the full observation setup, meaning you really understand what's going on in your infrastructure. You know about every event in each of the system that's there, regardless of whether it's mainframe environment, regardless of whether it's your private cloud, public cloud, computers of your employees, or the phones that they are bringing. You need to know what's happening there. If you don't, you won't be there. And the policy enforcement point must be there, and every access must be consulted with it. And as I said, the policy administrators we are talking about that say what is current policy cannot be accessed directly by the services. Otherwise, it brings risks and vulnerabilities. So what are the risks that are still staying? Even if you have really good implementation of the zero trust architecture, there are, again, always the pain points. There are the ways how to attack, there are the ways how to get the access. So some are obvious. We already stated that everybody has to have access to the policy enforcement point. Once this is not true, you are, I would say, fucked up, more or less. Because then the services have to decide, do I reject everything? So either you are not able to do anything, or you just allow control for something that you shouldn't. So the DDoS is far bigger deal when you are in the zero trust architecture. Another important problem is if the attacker can change how the policy is built. And there are two different places where it can happen, either in the decision process deciding whether this specific person is this person, or in changing the policies themselves to allow certain attributes that shouldn't be allowed. And if you know which ones are allowed, even though they shouldn't, you can, again, use it to get to the system. And the non-person entities is actually pretty interesting because in the other areas you want them. Like you want the service level accounts that have the limited access and everything. But within the ZTA administration, you should never get them. The person should really be there, and you should be as strict as possible when enforcing their rights to get there and the authentication. Because that's the most important point of your ZTA, and verifying that the person is who he says it is, and that they have the rights to the service. And the last, I know everybody of you saw this, like right now there are so many solutions that claim that they will give you the zero trust architecture. The answer is they won't. It's a terrible process and difficult process, and it's not about any specific solution. But it's building the vast amount of the proprietary and unsupported formats that doesn't communicate with each other, that just promises the silver bullet, but the silver bullet is not there, sadly. So, within Zowe, the most important part is the API mediation layer. API mediation layer is serving as the gateway to the mainframe. So this is the place that should be exposed for the customers to use. So whenever anyone is coming to the mainframe or mainframe APIs or Zowe, they should be doing it through the API mediation layer. It should be the only open port to the external world. And it's the place and the tool that we will see how it can help us and what's the role it plays in the architecture. Here you can see an image how it could look like. The API mediation layer takes care of this SSO and showing you information about your services and so on. But I guess you've heard about this a lot over the talks in Zowe. So these are the 4 areas where the API mediation layer can be integrated into zero trust architecture. So first 2 are authentication authorization, and it's possible to extend the API mediation layer provide in a way that all the data and all the service and all the informations will go to your PEP, policy informant point, so that you can use all the data within the API mediation layer as part of your decision process, and also consult whether the request should actually have the access rights based on your PEP. So this is the first 2 parts. As for the observation, we have some solutions to propagate the data out of the API mediation layer. I will be showing exactly how they look like. We have 2 at the moment that you can integrate in your observability solution. And for the DDoS, because API mediation layer, if done properly, will be part of PEP and will be accessing it and also can prevent the overload, you want the API-ML to be highly available, and you want to rate limit how many requests is actually going to PEP, so as not to overload it. Yeah, I basically talked about this mostly already. The only thing to mention is that what's being worked on now is the integration with the distributed identity sources. So some of the things that I'm talking about now and saying, hey, you might need to extend, but you can make them out of box in the next versions. Yeah, so this is some like bit of a knowledge for the operators if they are installing the API mediation layer. API mediation layer and Zowe supports MFA, but there are limitations. We are currently we are currently showing the ones that we know of, and it's that we don't support out-of-band MFA. It must be in-band, and when you are using Zowe as MFS authentication provider, which is the typical use case, you need this specific APAR to be applied. Why it's here, it's for reference. If at some point you are going to install or let someone install, you can find here the exact numbers. And that's basically it. We support, so we tested it with the CA solution and the IBM solution. There is probably some other on the market, but these are the two ones that we know that were tested, that it works properly with them. So this is a bit around authorization, because there are few things that Zowe and the APML specifically are doing around authorization. First of them is personal access tokens. It's possible to ask Zowe to generate the personal access tokens, and the token is limited to specific service. So for example, if you have a pipeline in which you want to access Endeavor, you can create a token that can access only Endeavor and nothing else, which is actually a good thing. Identity federation, this is where we are linking towards the distributed identity provider, and I've already talked about it. And self-access checks, the Zowe APML provides the API that you could use to verify that the specific user has the specific self-authorization in the system. So you can build on this to build distributed APIs or another mainframe APIs that doesn't want to integrate directly with the system to access this information anyway. And we are using it for some specific resources and some specific things within the API mediation layer that we consider risky. And now let's go to the observation. Within the observation, we have two solutions. One is the monitoring service. Monitoring service is fully public, open source, and depending on the Zoole infrastructure and Hystrix and Netflix part. So basically what it is, it's a standalone service that shows all the information about the requests that are going through the API mediation layer, but it's showing the current data. You can't go to the historical data with this. Apart from that, we created for now a proprietary extension. Maybe it will be open source. It's a discussion that's happening, which allows the integration of all the API ML data into other systems. We are verified with the Elk stack and Grafana and Kafka. And this is a very good part of the observability solution that can then integrate further with the platform. So as for the monitoring service, actually monitoring service is integrated with Zebra, which is another solution that's part of Zowe. So you can see the data about the CPU usage and other information on the system itself. And at the same time, you see the current information about the requests. The things on the part shows the load on the system at the moment. This is how it looks like for the requests. So you see there are some amount of requests that are more or less succeeding. I think these are all succeeding. So for the audit log extension, this is still a proprietary thing, but it may become part of the open source. It's mainly focusing on Elk stack and on Kafka, because Kafka is possible to use as the source for any other visibility or observability solution that you know of. This is an example of requests and how the requests are being kept. So all the information about the authentication, about how long does it take, what exactly was happening throughout the system is part of the audit log. Where it could help you is for the operators to understand and look for the anomalies. But again, it's probably better if you directly feed the data to Kafka and have some automated system like CM that would actually understand it and based on this integrate it in the PEP. So this is an example how it could look like for authentication. This is from the system that we are actually running. And you can see the graph that's showing, okay, there is lots of requests from specific users, but it's okay. We know that they are testing with it. And the last piece that was mentioned in its part is the high availability. So one of the things is, of course, prevention of the downtime. it's why you have high availability. It's theoretically possible even to do the zero downtime upgrades of Zowe itself, but it's a bit tricky. But you definitely can use all the functionality to do your own deployments of your services, like blue-green, canary deployments and stuff like this. And APIML has actually pretty good tooling into how to do this. So that's about it. Like, I'm not sure if there's anything else. It does include some amount of limiting the rate of the access to APIs, but we will be improving this in the coming releases. Yeah, and a bit of the configuration tips. So if you are deploying Zowe and APIML, it's good to operate it and deploy it securely, which means some things like you should use TLS. First, you should use TLS. Second, you should use TLS at least 1.2. Second, you should use rather either the tokens, regardless of the JAT or the personal access tokens or the client certificates. They are well supported within the Zowe and API mediation layer. You should use the ZOSMF as authentication provider, and you should use the MFA setup. If you are not doing it, please do this. And you should have it done in the HA setup. And we do recommend, if you are using the caching service and virtual desktop, to use InfiniSpan as the provider, because it works well on platform, off platform, and it doesn't require spanning a new task, and it's easy to configure. And that's all from me. So any questions, anything to add to the topic? I see that some of the people didn't fall asleep. I'm glad about that. Yeah. So the question is whether it would be possible to use the data from the audit log to get access to the systems. And the answer is no, because the data in the audit log, as we are providing, doesn't contain sensitive information. We are masking them and removing them when already sending them to the system, because that would be actually really dangerous. We keep just who is the person. We don't keep the token there. So thank you for the question. Any other question, any other concern? Yes, it does go to the server.xml. Okay. Yes. So the question was around the multi-factor authentication with ZOSMF. And for the ZOSMF, the parameter that needs to be added, that's part of the presentation, needs to be added to the server XML. And this is actually easily found in the documentation. So if you know that you are looking for this specific piece, then Google will find it. Okay. Any other? Sure. Okay, so the question was who within the organization would be expected to analyze the logs. So in general, the logs will be integrated into the policy enforcement point. So the people that operate the policy enforcement point will be the ones that will be responsible. But apart from that, there are two other categories of people that may be interested. One of them is for the purpose of auditing. So the auditors that you can prove that things happened or didn't happen within the system. And these are like, I don't know, internal auditors, I guess, are the people. And the other group of people that may be interested are like the system operators. They could use this information to build a dashboard that's showing the system operators the system is still fine, things are green, everything is going well. So I would say that these are the main groups that I would expect. Thank you for the question. Any other questions?
Main component is then that and drop that into your
Yeah, so the question is around PEP and whether it's like how you would integrate this in the architecture. So the answer is yes and no. Like, it's easy to add PEP. This is not the difficult part. The difficult part is to link it to all the data, because you need to integrate across all the systems and platforms and everything you support internally. And in changing all the services or some gateways or some other resources that make sure that everything is accessed correctly, that they actually go to the PEP to verify data. So that's where APIML would help for the mainframe APIs, because you can integrate on the APIML and you don't have to integrate for every service. Or at least it could simplify the integration for, because technically speaking with ZTE, you should also do it for every service. Because there still could be a malicious actor between the gateway and the service. But that's a bit tricky already. This one, yeah. I think the data are coming from there. This is, I think, on 7558. So it's a separate service that you can or cannot enable, but it's part of the default core. Like, so when you install Zowe, it's there. It's just that by default is disabled, but you can enable it and then you get this information. These data, yes. It's actually using historic streams. So if the customer can consume the historic streams, they can do it. Or, as I said, the alternative that we did is that we use the capabilities of the logback to push the data outside of the API mediation layer to other solutions, such as Logstash and Kafka. Like, anyone can do it, technically speaking. Okay, thanks for the question. Yeah, sure. So the question was whether in scenario where we are recommending and talking about the Zowe SMF as the authentication provider, I forgot the second part. Whether it's applicable in the scenario where only in the scenario where APIML is not used. That's not true, actually. APIML depends on Zowe SMF in this functionality. Like, we would be able to do it in the scenario where it's running directly from SAF, and then the APIML is responsible itself, and it works as well. But we don't test this scenario in our nightly pipeline in Marist. So I can't prove with every minor version that it still will work. But it probably will. And in the Zowe SMF scenario, the APIML depends and uses the JAD token and the authentication from the Zowe SMF. We are not doing any more. We are doing lots of magic, but not in this area. Like, we just transparently go and ask Zowe SMF, give us the token. These are the information that you need to decide whether you can give us the token. Okay, thank you very much. Any further question? Okay, so thanks everyone for joining. Thanks for the questions, and I hope that there was at least something interesting and new for you. If you want to know more or you are concerned about anything, feel free to reach out to either Zowe Security Work Group, directly to me, or via any Zowe channel on Slack. And have a nice flights and afternoon, whatever is it you have.